I hope you can see my screen. I hope you can see my screen, right?
Yeah, we
Yes, sir.
can.
Yes, sir.
All right, so we'll start ML internals. I assume that you are good at executing parts. You know every block of it, but at least the purpose of it. Then we'll get into ML internals. The script is the most crucial one, very important one. That this will help you to understand what exactly will happen in an algorithm after it started training under the hood. So let's take that we have taken a very simple data set wherein X is the input and Y is the target column. I've taken some random data, so nothing much significant. So you can ignore this part. You can, after loading the data set, right? You can import this one and this one again, this one. This is not necessary, in fact, this one, and you can straight away jump to this part, gradient descent. Gradient descent is the mechanism wherein it will help us to find out the right parameters. And this data is going to assume that and it's actually a simple linear regression algorithm. So basically it assumes the data is linear in nature. If we know one algorithm, then we can at least assume that how things, how things are going to work under the hood. So this is the manual way wherein my suggestion is to take the pen and paper. Okay, so do it and try to calculate this manually. I will explain this in detail. Try to calculate it manually. Whereas this part is basically the automated way. I mean to say that we can import the algorithm, we can take the data set, we can split the data, trying to split X and Y, right? So in all the input columns will sit in X and all the target column will sit in this Y. And test size is 0.1, which means 10% for test size, wherein we can use it later for evaluation to find out how good the model is. So we can see that linear regression being imported, and where it comes from, it again comes from scikit-learn linear model. So we need few reshapes here and there to make sure that the simply regression would take it as it is. Whereas the actual way of reformatting whatever, you can follow the template. This is only for a simple data set and only one algorithm. So these sort of things need to be done, but not in all the cases. So once we fit it, we get the parameters, right parameters. Here in this case, the linear regression y equal to mx plus is the formula. And here, I think this is m and this is c, if I'm not wrong. Well, so this m and this is c. So m equal to 1 and c equal to 3. With these parameters, the model is going to be y equal to x plus c. So x is the input. So when we provide some input to it, it is going to find out, let's take 2 has been given, something that is unknown, and 1 into 2 plus 3. So that is 4. So 4 is going to be the predicted value. I'm still not sure whether it is m1c or c and m. 1 second. Y equal to mx plus c intercept. The number c is called the intercept. All right. So this is c and this is m. And the okay, of course, we can get the parameters in a more automated way. We got these values just by after fitting it once we have this import. But what will happen really under the hood? That matters a lot. So this is one algorithm wherein it's going to go through 5 iterations. I had given 200, maybe I was testing it. Go with 6 iterations when you do it manually. 6 in the sense 0 to 5. So I can say that it's going to 5 iterations. Or I think it is, now this is 5 iterations. We go with 0, 5, then it's going to be 5 iterations. So 5 iterations in the sense, it's going to go through all the rows and then again goes back, all the rows again goes back, all the rows and again goes back, all the rows again goes back. So 5 times it goes through go through all the rows. That is what this range does. Initially, we don't know the parameters. Y1 and C, B0 is 0 and B1 is 0. We're going to start with those values because we don't know the exact parameters. So only when we have that right parameters, we can get the model, right? I think I explained this with 2, 4, 6 simple example, 2 into position. So how do we get this 2? Based on the data we have. Right, the same way when we give 3, 6, 9, it's going 3 into my position. So 3 is going to be the parameter that we found by looking at the data, by understanding the data. The same way here we have two parameters, B0 and B1, wherein we don't know initially what those values are. At the end, we need to find out. And alpha is basically how much percentage or how much proportion that we have to increase for the next step. Right at the first phase itself, obviously not going to be the right values. We need to keep incrementing it or decrementing it at rate of this one. So 0.01 means 1%. So we're going to increase to, we're going to jump at a rate of point. See, let's say this is the one. We're going to increase at a rate of 1%. Let's say that is 10% is going to be like this. Okay. Let's take 5% is going to be something like this. So what will be the next value? How do you find the next coefficient parameters? This alpha is going to be one of the dictating factors. And delay I have given it, so just give 5 seconds so that every step is going to be printed one after another with 5 seconds so that you can clearly see the steps here. Okay, and yeah, I hope this part is clear.
Sir, you told it's a linear, right? So what is the graph that you draw?
Obviously, it's going to be like this. So you should not get confused with this one because this is the gradient descent. It's optimal value parameter. Optimal parameter, the bottom part.
I mean, 1% per day. Yeah, there is a comment, right? What is the meaning of that? Sorry,
I
one
said
page a day.
no, that is totally different. So 1 page a day in the sense at least practice 1 page a day. I would have written that way.
Okay.
We can ignore this completely. All right. So any questions? Of course, you can reduce the delay, but you can't see step by step. Let me execute this once, but you'll get a better idea. So your first iteration is going to go through that. Initially, we assume that it is 0, 0. What are the inputs? The first row is going to be what? It's going to be
1.
yeah, 1, 1. So it's going to, input is going to be 1 and the output is going to be 1. So we feed it this one. I think this is totally different data sets. I think they change the data set, not 1, 1. We came up with something. Yeah, I think this is this one, this part. This one some other gave an example. So 5, 16. So 5 is the input, target should be 16. So we have taken 5, but in the parameters are 0, 0. So obviously it's going to be 0. So what is the error? It's actually 16. We have to get 16, but what we got is 0. 0 minus 16 is minus 16. Minus 16 is the error. Now we need to recalculate the coefficients again, B0 and B1. How do we recalculate the coefficients? B B0 new is equal to volt B0. What is volt B0? 0. Minus alpha, that is 0.01 into error. What is the error? Minus 16.0. So when you calculate this, we get new B0. So what we got here is 0.16. Because we multiplied with 0.01, right? 16 becomes 0.16. So the new B0 is 0.16. The next step is going to be finding out B1. What is the formula for B1? So B1, old B1 minus alpha into error into X. Input, we need to multiply even the input. So it's going to be 0 minus 0.1 into minus 16.0 into 5. What is the first row value? Input 5. So we got 0.8. So new B1 is 0.8. And then we need to fit these values into the formula y equal to mx plus c. So what are those values? 0.16 for B0. Now it's 0.8 for B1. So we need to fit this as 0.16 plus 0.8 into what is the next row? What is the input for the next row? It's 10. 10 and target value is 31. We have to get 31. So target value, sorry, input value is 10 and target value should be 31. So after calculating, what we got is 8.16, but the actual value is 31. So there is a huge difference, right? 8 minus 0.16 minus 31. So it's going to be around minus 23 or something. What the error is going to be. The error is going to be around minus 22.84. Now again, we need to recalibrate the coefficient, just like the way we did here. Right? B0 and B. What is the new B0 and B1? B0 old new B0 equal to old B0 minus alpha. What is the old B0? 0.16 is the old B0. 0.1 minus alpha into alpha is 0.01 into error. What is the error? Minus 22.84. So minus 22.84. What we got is around 0.38 something. 0.388 something. So this is the new B0. What will be the new B1? Is the old B1, that is 0.8 minus alpha into error into X. What is X? It's 10, right? In that particular row.
Yeah.
So it's going to 0.8 minus 0.01 into minus 22.84 into 10. So 0.8 minus minus of minus 0.2284 in 10. So going to 0.8 minus of minus is plus, right? That's the reason we got plus here. So it's around 3.08. So 3.08 is the new B1. Again, we got new B0 and B1. We need to insert into y equal to mx plus c. What is the new x then? What is the next row?
15.
Yeah, it's 15 and 46. We better copy this so that we not to keep on scrolling up. All right. We are inserting the new coefficients in y equal mx plus c. Is a c plus m into x. What is the row here? So what is the value? Input is 15. So we have to insert 15. What we got is 46, but the actual value is 46 in fact. So the error is going to be drastically reduced, 0.64 now, right? So we need to recalibrate the coefficients based on the error. So how do we recalibrate the coefficients? B0 new one. Scroll down. B0, new one is equal to old one. What is the old one? 0.38 minus alpha into error. What is the error? 0.01, alpha is 0.01 and error is 0.64. So 0.64, when we multiply it, it's going to 0.0064. So it's going to be, new B0 is going to be 0.38191. So again, we need to calculate the coefficients, the new B1. I hope you're getting the picture, right? So we need to do it for every row and we need to recalculate the coefficients. New B1 is going to be the old B1 minus 0.01 into the error into that particular row. So what is the input value? So 15, because that is the one that we have to feed. And the new B1 is going to be, so it's going to be this 2.98 something. And we need to insert to the next row. What is the next row? It is 20 and 61. Right? So B0 is 0.38 and B1 is 2.98 something. And after inserting it, and the next row is going to be 20. So we need to multiply this with 20. And it's going to be around 60 plus 0.3, 60.3 something. 60.116, right? That is the value. But what is the target value? 61. So 61 minus 60 minus 61. What is the error? Minus 1 something. You can see that minus 0.88 something, right? So again, we need to recalibrate the coefficients. After computing for all the rows, whatever we get the new coefficients after recalibration of coefficients, whatever the coefficients we get, M and C, we need to again apply it to this one and next one, and we need to recalibrate the coefficients again. We do it for 5 iterations. Of course, we can have more. When you look at this linear regression, you can have at least 200 to 300 iterations. Are you getting the point? How these models been built internally?
Yeah.
So for the first iteration, why was the x not multiplied?
X is B0 is not multiple. B0 formula is this one. We don't have X. Whereas B1 we have. In fact, we did.
Okay, I thought that was busy. Sorry.
No, first iteration, yes, we did. It's 5, right? So B0 formula and B1 formula are totally different things. All
So
right,
is
so
there a why we
go
should
ahead.
multiply x with the B1, not with the B0?
What?
So is there a reason why we should multiply x with B1, not with B0? Like mx plus c, is that the formula? So you are calculating that one.
No, we are recalibrate. This is the formula for to recalibrate M and C. This is C and this is M. Those are the formulas that has been derived after experimentations. So that is how
Okay,
we
so
recalibrate the coefficients.
the inbuilt formula. Okay.
Yes, that's if you look at the scroll up, you can find the formulas too.
Normally, how we can know for what type of data we should use which algorithm or model, like in the real life, where to use which algorithm or the model?
So
How
in
these
terms
are
a template, we have seen we have used multiple algorithms. Why do we? I think already discussed about this point. So we use multiple algorithms to generate multiple models because we don't know what data is going to fit to which algorithms. Based on the accuracy, we need to judge which algorithm is better generating the better model, right? You already saw that one. I think I brought that point while explaining the template. I don't know how you missed that. Go ahead. You have a few more questions.
yeah, like in the real life for a AI engineer, like how he can use these algorithms or the models while he's working for a role.
Yeah, that is what that will come a deployment. Right now, stick to generating models, and then deployment phase, we will see how we can deploy it in production. We need to create an API for it.
Okay.
So, and you need to wait till then.
Okay.
All right. So what you have to do is you need to do it for five iterations at least. Do it manually. Try to calculate it manually. Watch this once. Keep no, it's going to keep on executing. I will stop right here itself. Right. But what you need to do is by looking at this, execute it at least. If you want the whole thing, you can simply skip that part. 0, make it 0. You're going to get the whole script immediately. So take the script and try to do it manually so that you can understand it. Uh, so whenever I ask you to practice in a certain way, practice it blindly. Don't try questions. Then you will understand it later, the later part of the course. Okay. So even I think most of you haven't done what I mentioned in ML projects, ML template phase. You have to take every data set and keep repeating what is the purpose of the block. That has to sit in your mind. I don't know. I think you have done for one one go with one data set, and thereafter it's simply running all.
So this is the manual work, and if you use a scikit learn that one library internally, follows this one, right?
Yes.
Okay.
Integration. So there are a bunch of more algorithms. The formulas are going to be more complex. It is not even possible to do it manually. So if you understand one algorithm, the other algorithms we need to understand the concept that is behind it, rather than doing it manually step by step, which is almost impossible. So one algorithm will help you to understand the core structure of what other algorithms will work and on what it is based on, what is the core structure, core mechanism that it is going to find out the parameters, the way it is going to find out the parameters. Right. Any other questions? And I am telling you again, this is very important and do it manually. What about others? Bharat, Naren, yeah, Bharat, Piyush. Are you practicing things like how are you practicing
Yes,
projects?
yes, sir. But a few things when running the template on that time, very means many of the
What?
time means I'm not able to understand that feature selections and
Yeah, that I told you that will come under ML internals. So those
Okay.
things that are not being discussed, I will discuss as part of ML internals. Today we have started ML internals.
Okay.
Okay, so the next concept is penalization. For example, give me one practical example, any practical example, not to be related to machine learning or whatever. So where do you think and we see this penalization, why we need it?
I
Alright,
don't know.
penalization, penalty, some
Okay,
fine, penalty,
Yeah,
yeah.
yeah. Okay,
Yeah.
if we are not filing any tax or in time, any payment, credit
Okay.
card bill, tax. I think,
So, yeah, what kind of, how much amount you have to pay as part of, as penalty?
Depending
again,
upon
depends upon that, yeah, work. Suppose IT returns 1,000 rupees.
Hmm.
Some other cases, some percentage of actual amount in case of credit.
It fluctuates, it's not constant.
Yeah,
Change from person to person and even the same person from year to year, or depends on various, lot of parameters, right?
activity. Yeah.
The same way, when we have a data set like this, let's consider that we have a data, something like this. Sorry, something like this. Let's consider this is regular data and data is linear, so we can easily find out the model. What if we have something like this? By mistake, someone would have entered some wrong values, extreme negative values, extreme positive values, extreme low values or extreme high values.
Like
So
outliers.
yeah, outliers. That is outlier, remove outlier is one way of doing it. And the other way of reducing the noise is penalization. So we have something called L1, L2. So more you have the noise, and let's say that you have a lot of noise, then apply L2. Then if you have less number of noise, less amount of noise, then you apply L1. So in this case, what happens is like when we don't remove this, when we don't penalize it, it is going to even consider that way. Even when we don't remove outlays, it's going to the model is going to assume that this is the real data and is going to generate a model that is going to fit well, fit to this one. So understanding even understanding the noise as if it is real data and generating a model on top of this is basically what we call it as overfitting. So regular data, whatever that is necessary, understanding it and generating model, that's fine. But even considering the noise is real data and generating model that fits even to the noise is what we call as overfitting. Overfitting in this over learning. Suppose someone has mugged up a question, right? A slight change in the question being given in exam. So he's going to answer the question. The model is exactly going to be the same way. So if there is a slight change in the input, then it's not going to work out.
More than what is needed. That's the thing, right? Overfitting data.
It's not, yeah, it's more than, it's even learning the noise. Rather than
Yeah,
learning the right data, it's even learning the noise, which is unnecessary data, that is going to lead to problems. And L1 is basically like when we have less penalization. The difference between this one and this one is very simple. It's not being squared and this one means squared. And basically, like f of x is the based on the data that we get, we need to apply the f of x. In addition to that, we need to add penalization. And lambda is basically the proportion. Let's take that you breach a traffic signal based on the reason, and the percentage could be 100% or 50%, 30%, or it can be 0%. So lambda is going to be like that. How much amount of penalization has to be? As per rules, it could be 1,000 rupees. But let's take that a person is pregnant. Then lambda is going to be 0. Let's take that you have a valid reason to that you convince the traffic answer. Let's take that in such case, he may penalize 130%. Then lambda is going to be 0.3. Right? So and the square is
Yeah.
basically the amount of penalization. So now we can, the only difference is not being squared, this has been squared. How do you calculate this x? The square root of p is the parameter that has to be found by the algorithm, and we need to sum up all the values power to the power p. So that is how we need to calculate this x. And how do we know which penalization need to be applied? Again, if you look at this closely, we have L1 penalty lasso. Lasso is nothing but linear regression with L1 penalty. Lasso, linear regression with L1 penalty. So ridge is basically linear regression with L2 penalty. There is another library, right? I think we in template, ElasticNet. ElasticNet is basically linear regression plus L1, L2 combination. What does that mean? So let's take if we give 0.2 L1 penalty, then L2 is going to 0.8. Let's take 0.5. This point is L2 is going to be 0.5. Let's take we have given 0.9. What could be the proportion of L2 penalty?
0.1.
0.1, simple. So that is how ElasticNet works. We don't know which one will work, but that's the reason we have this template, we have that grid to apply it on all the on all, I mean to say, I'm not getting the words, on all the algorithms, so it is going to generate the model and thereafter we can judge the accuracy. So in real world, that is how it works. It is humanly not possible to take the data, understand the data, and find out which algorithm is going to work well and which correlation will work well.
So as you told, that penalty will not be more than 1, right? By the, I mean, for L1, L2 or combination of L1, L2.
What do you mean by N? One. This
One,
is the
I
amount
mean,
of proportion. So proportion of which we have to take this penalization. Penalization can be anything based on the data. This is proportion. It's basically like a, kind of switch or like a fan thing. We can switch from one channel to another channel, right? 1, 2, 3, 4, 5, kind of that.
so do we have to remember this one, formulas and all?
From interview perspective, yes, but practical perspective, it's not required. As long as you understand the concept, that's good enough.
Yeah, okay.
Next one is scaling. Scaling is one important concept. I think, where have you seen this standard scaling in the template? Have you seen anywhere else? In template has been given scale, scalar, scaling. No response. I'm expecting a response from you. So by now, you should be in a position to immediately point out which block of the code that has the scale or scalar. After we import the algorithms, we have something called make pipeline. We have applied standard scalar on algorithm, right? So it's going to standardize the data and then it's going to apply the algorithm, isn't it? I don't know why you guys are not practicing well. I should not keep referring the same script again and again. So you can see the standard scalar. We have applied standard scalar here. It's not just standard scalar. There are a few other options too. Here we have min-max scalar, standard scalar. This is standard scalar. And we have few options like normalization. And bandation is not really scaling, but it's totally for different purpose. So the standard scalar is the best one that we have to choose, but we have other options too. So we will see in detail how this is going to work under the hood. So min-max scalar, say x minus x min by x max minus x min. That is the formula. So in this, what we need to find out? We need to find out the minimum value in that particular column, maximum value in that particular column. Let's take that we have a bunch of this one, and class is the target column that we have to find, right? And let's consider the preg. What is the max value in this, and what is the minimum value in this? Let me load the data set first.
40.
Once I think, yeah, here I need to import. You are looking only the this particular
First
five
box.
rows, five rows, but basically it's not possible. We have more than 5 rows. So in that case, what we can do is we can take the preg minimum maximum, right? So minimum val, max val. What is the minimum value? 18, and maximum value in that particular column is 42.2. And how do we find, what is the formula? X means each value minus minimum by x max minus x min. So let's consider, you can take any value you want. So we are calculating for this particular column, right? Let's consider 36.7, okay? 36.7, going to 36.7. What is the minimum value? Oh yeah, we already have minimum value and maximum value, right? So what is the value we got? 0.77. So after applying it, you can see that we got the same thing. Of course, the mechanism is going to be different. We have much better way to do that. So we can import min-max scalar from scikit-learn, which is basically part of pre-processing component. And feature range, basically we can ignore it. Basically, the idea is to get the values between 0 and 1. We can even fix that to 0 to 2, whatever, but usually you go with 0 to 1. All the values are going to be between 0 and 1. And we need to consider as if it is an algorithm, and fit transform is the one that we apply for pre-processing steps. Usually for the final model, we're going to apply only fit. Whereas fit transform is basically, we are using this, but this is an algorithm in fact, but it's not for generating the models, for pre-processing, data pre-processing. So this scalar algorithm is going to fit to that data so that it can understand the pattern in it and going to apply min-max scalar for every piece of data. So that is how we got this 0.77, which matches with this one, right? Let's take another value. Let's take 36.1. Okay. So we are going to the same column. And of course, you can take another column too, but we need to calculate min and max for that, right? So 0.7479. What is the row? 1, 2, 3, 4, 5, right? A fifth row. 1, 2, 3, 4, 5. 0.7479. Is it matching? 7479. You can take any other column and cross check it to find out whether it works or not. Any questions on this part? As long as you understand how to calculate the min-max scalar and cross-check whether it works or not, that is good enough. You're not understanding the remaining part of the code. Of course, it's the same from the template, but it is on each component basis rather than for all the algorithms, all the whole data set. Yeah. Any questions?
So, how do we know that from the? I mean, you have given the template, right? But how do we know that from the scikit-learn library, which is one we should import and all?
Yeah, that is the reason I have given standard scale. Standard scalar is the best one compared to any other. You can change if you want, just by importing min-max scalar. You can import it. That's not a big deal. But the best one is obviously standard scale. That's whatever you have it in template is the best ones. If we want to try with other options, I had given it in the grid itself. This template took a lot of time to prepare. It's not that easy to, it's not as easy as you think. Right? Any questions? You need to respond. Desperately asking you whether no, you need to be
I mean,
active, you need to be
we have to.
interactive. Yeah.
I mean, I have to go through this one, and again, I will.
No, did you
If there
understand
is any,
min-max scalar concept? That is my question. So
this one is okay. Just for this
okay.
one, what you explained, that I understood. So.
Okay, so just stick to that then. So when you like when I say this one, obviously you need to practice the template first, right? So if you don't practice, obviously you're not going to refer it back. And you're asking me what is the and where do we use this min-max scalar? Whether we need to use min-max scalar or something else. I told you that standard scalar is the best one, so we have used here. If you want something else, you can of course import it. You can use the same script, right? To import the remaining things. You can see min-max scalar. Instead of standard scalar, just replace that one. That's it. But don't use min-max scalar because that is not the best one that you can pick. Standard scalar is the best one. So
Okay.
yeah, go ahead.
Yeah, so I thought that, sir, you have given the template, right? So you have written that code for everything, right? So my question is that until that one, the scaling of that one and the cleaning of the data and all that we understood. But later the part we are fitting the model and all, right? So in that one, as you given the assignment, I didn't understand that part. So
No,
I
I
had some.
clearly told you in the, I will explain template itself that whatever the comments that are missing, I will explain in detail later. So
Okay,
I
that is
don't
not
understand
needed.
why you are not stand scalar been explained. Now
Yeah.
at least you would have been in position to map it over there. That particular block we have this concept. So I am expecting that kind of thing. So you are keep thinking about things that are not being
I
discussed.
thought that is relevant to this one. Sorry, that is not required now. Okay.
All right, the next one is standard scalars. The formula is going to be different. Each value x, whenever you say xi, it's going to be each value in the particular column minus mu. Mu means mean by standard
Population.
deviation. We know how to calculate mu. We know how to calculate standard deviation, right? So we're not to get into standard deviation again. So just this formula. We know just if we provide a column, we have the way to get standard deviation mean directly. We can cross check it easily. Let's consider that I'm going to take another column altogether, mass. What we need is each value, and we have mean and standard deviation we need to calculate. So go with that one. What are the standard deviation and mean for this particular column? 1 point. I am taking this to cross check whether it works or not. So standard deviation is 1.29 something, and mean is 4.07 something. For the same data set, and okay, even before applying this, let's this is mass, each value minus mean by standard deviation, right? This standard deviation formula. Okay, we can even calculate this. Yeah, I think it's matching with this one. I would have given the, and I would have copied directly from the standard deviation script. The script has already been given, standard deviation variance.
This is for the population, right? The formula.
Yes, because it shows that mu, but even if you consider sample, it's going to be the same formula, right? The only thing is notation, the way it is being notated is going to be different. We don't know what this data, whether it is population or sample, it doesn't matter now, but we can get the mean or standard deviation the same way. And the standard deviation we mean, so we can just apply it on one of these values. Let's say 4 minus, we'll take 4 here. 4 minus, what is the standard deviation here? Standard deviation will come the denominator part. That's the formula, right? By standard deviation. Mean is this value. So what we got is minus 0.05. Let's cross check it. What is the third row in mass column? Let's cross check with this one. Mass, okay. So 1, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Okay, this one. Minus 0.05. Is it matching? Minus 0.05.
Yeah.
So you can cross check with other values. Okay. Just calculate for 2 to 3 values so that you can understand it better. And the next one is, any questions on this part? Standardization.
No.
Next one is normalization. Okay, just take this data set, but this normalization is not across column, is across row, is over the row. The better phrase is over the row, not over the column. What I mean to say, this is the formula, right? Each value by square root of xi square plus yi square plus z square. It is not limited to just 3 columns. Just consider that, this is the data set, right? Suppose if you want to normalize this one, we call it as normalization. It's 41.3 by square root of each of these values being squared. Okay. This one across row. And what is the value? 168. 168. 102.8. Let me know if I'm going wrong. 36.0, right? That is that. Yeah. Is this the one? Yeah, 37.0. 5.0, 5.0, 4.9488. I think they already have 4.9488 and 94. We should not include the target column. This is the class column. I'm going to calculate it. This one. What you got is 0.1725. Let's cross check after applying the usually X and Y applying the same process. Here we have given fit and transform in two different things, but we can apply even fit transform straight away if it allows. Okay, there's nothing wrong in applying fit and then transform or fit transform. Think which column is that? Which column we applied? 41.3. So, yeah, this one. Pregnancy,
First
the
one.
preg and first value, right? 0.172514. Let me copy this and cross check. Where is that? 0.172514, 0.172536. Because the patient is much larger, so it's quite obvious that 36 would have been rounded to 4. Right? Fine. So
Yeah.
I hope you got the point. You can cross check other values too. So that's not a big deal. The next one is binarization. So any questions on normalization?
So what if there are multiple more than the values which you have taken now? So
Obviously, it's going to be the same process. We need to apply the same thing. So you should not
So-
include target column. I need
Yep.
to keep squaring it. You can take any value and it's going to normalize.
we can write the formula using that sampling also, right? Can we do that?
Sampling what?
I mean, first row, all the column value. I mean, there are like 50 columns or something. Do we have to do this for every value?
Are you going to do it in manually or what?
Not manually. If it
But
is a
no, I'm trying to
automatic.
explain how it's going to work under the hood by calculating it manually. Otherwise, we already have this one. Normalizer
Okay.
is going to normalize. And binarization. Binarization is going to be like either 0 or 1s kind of. We need to give threshold. So binarizer threshold, anything that is, you can see that there is anything that is greater than 50, because based on threshold, if you give something else, it's going to be like this. The threshold will change. Here I have given 50, so greater than threshold is going to be 1. Less than threshold is less than or equal to threshold is going to be 0. So when you apply this, it's going to be all zeros and ones. So we don't really use it as part of scaling. In very rare case, I mean, in order to convert a color image to black and white, that sort of case, I haven't used in real world, projects, real world projects. So it's very rare that we use this one. Right? Any questions on scaling?
No,
All right, so I'll stop right here. We'll discuss other concepts. So go through the scripts, try to understand it apart from what we discuss. When you keep exploring yourself, because I will share scripts today in Google Classroom. You can download from there. And ML intelligence is very, 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 very important from interview perspective or even from understanding the whole machine learning is right here in this folder. If you understand these concepts, more than 70 to 80% is more than enough. It will take at least 2 to 3 years to learn these concepts. So utilize it in a way that we are getting all the data in one place, rather than feeling lazy or so lack of practice. Definitely kill the whole thing. I request you to understand that practice as much as you can. Whenever I say you need to follow in certain way, follow it as it is.
Sir, I have a doubt regarding the assignments you have given, sir.
Go ahead.
I understood that you have given those templates and we are inserting that based on the value counts, we will get that binary or multiple class, right?
Right.
Yeah, we are inserting that CSV file and we are running cell by cell. But after sometimes, I mean, based on the class, what we have done, I understood that sampling and I mean, cleaning the data and everything till that part. So after that one, what we need to understand, I'm not getting that one, sir.
What are all the parts that I have explained? Try to
Yeah.
understand only that. The remaining parts are going to be covered. I don't know how many times I need to say it.
So I understood only till the sampling. Is that, I mean, the cleaning part that you,
Yeah, exactly. That's exactly what you have to understand.
yeah, okay.
The
I mean,
grid part is going to, if you understand how we imported it, that is good enough. Hyperparameters, you
okay.
not to understand. The grid part, of course, it generates the model. If you understand that part, that's good enough.
Okay, till
Then
the
accuracy
sampling
part
and
is going to
cleaning
get,
understood.
yeah. The remaining concept, at least you need to understand the purpose of it. Leave
Okay.
about the
Because
code.
of those libraries and all, they were new to me, right? So I didn't understand that parts and all. So I didn't really get it at all. So that
You need
was
to
my
watch,
doubt.
you need to watch the video and find out what is the purpose of each block. That is more than enough.
Okay, okay.
By the end of the machine learning internals, you will understand, you can go through the same template again. You can understand every bit of it. All right, that's it for today. If you have questions, let me know. And you need to be a bit fast and active more. Otherwise, it's difficult to cover a lot of concepts and take a lot more time. So I request you to understand, practice more, and be active, be interactive in the session. Or otherwise, from here onwards, it's going to be quite steep. Learning curve is going to be quite steep. For next 2 weeks, it's going to be quite hard. So you need to keep practicing projects again and again, even if with the same data set, try to practice, try to understand the each block and whatever the concept we discuss in ML internals and deep learning thereafter, you need to practice as much as you can. It's more theoretical, less practical, but I will try to present as practical as possible, like the way that I did now, for scaling or whatever. Okay. Yeah. Thanks for joining.
Thank you.
Thank you, sir.